Okay, so how we deal with these transformations in chapter 5 or section 5 is you got to think I have all these a times f of b times x minus h plus k. So that's the vertical up down shift, that's the left right shift. This determines the horizontal, whether it's been reflected around the y-axis or it's been stretched or compressed horizontally, and that's the vertical stretch compression. And if that's negative, it gets reflected around the x-axis. So for this question here, this is my version of it. They said so the graph of G is obtained by reflecting the graph of f about the x-axis. So that tells me I'm going to do negative f of x. And then we want it horizontally stretched by a factor of 3. So the way you get that inside done is you say, okay, they want it to stretch by a factor of 3. I'm gonna put it 1 over whatever they're telling me, and then and it's not shifted up or down at all, is it? So it's going to be plus 0. Okay, now how do you remember this stuff? Well, if you go to let me get a pointer going here. And if you go to, oh, I don't have why can't I see my book? Okay, just a minute here. That's a spreadsheet. Here, I'm going to stop my share for a minute. I'm going to come back in, open up my PDF displayer, and I'll come back here and share my screen. Okay, so I'm in the PDF from the Lippman book, right? And you know how to get to the Lippman book, right? You go and go, I'm gonna have to reopen this. Lip, if you just do, I've got it linked in the course, but if you just Google Lippman Open Pre-Calc, it takes you right to why is that showing me? Here, right here. And then you can download the PDF of the full book for free. What does that look like? Well, it actually looks pretty good, I think. Here, let me come back and do this. Let me maximize that. Let me come back to Zoom and let's share my screen. So what you do with a PDF is you get all the chapters here, and this is chapter 1. You can do the drop down, and then this is chapter 5. Here's the textbook. Here's all the explanations and all that. And this is where they tell us about all the different parts. And you can look at I would certainly look at these boxes, right? And then there's these examples you can look at with the worked out answers. See, there's the up down shift. We didn't use that here. Um, let's keep going. And then the horizontal shift is inside, and we changed the sign with that, right? And then where's the horizontal stretches and compressions? And there's the reflection. So that's when it's outside. See, when it's outside the function and gets reflected around the y-axis. See, when it's inside the function, it gets reflected around the y-axis. When it's outside the function, it gets reflected around the x-axis. And they talk about it here. Let's get down here to the horizontal compressions. I'll be honest with you, um, that's the part that confuses people. And honestly, you always used to confuse me until I got this idea that you're going to take whatever they tell you the stretch of compression is horizontally, you put it 1 over that, and that'll be how you write in the equation. Okay, so if they wanted me to, if they wanted me to, here I get a Desmos graph. So I like using the square root function because that shows up well. Um, can I get rid of my history here? So here's the regular old square root of x, right? And then if I make it be 1/3, like what this is wanted, see how it stretches it out longer? It takes longer to grow as fast as the regular square root of x is. And then if it's a 3x, so if they wanted to compress by a factor of 1/3 is how they'd word it, it'd be 1 over 1/3, which is 3, and see how it's growing faster. So any of these any of these horizontal translation, any horizontal stretches or compressions can be written as a vertical one also. If I wanted to write, the one third square root of x, I could do square root of 1/3. I don't know why I put that extra parenthesis in there. I didn't need it here. And then I'm going to go outside it, and then I'm going to do the square root of x. And you see how it's exactly the same? See if let's undo that. See if it's the same graph. So we can always do that translation. Works nice with the square function too. I'll let you play with that. Okay, long enough video. I hope this helps.